All right, guys. Anything else from homework that I can just not answer and say we'll get there eventually? Huh?
I think it's just like everything that the independent.
Which one? 36. Which one?
3.1.
Which one? 36?
Yeah.
Okay, so 36. All right, that's beautiful. So one of the first terminology bits that we didn't talk about directly is something called sample space. Right? It's not final space, just sample space. All a sample space is a collection of all the things that could happen. So for example, if I roll a normal die, a six-sided die, not a Dungeons and Dragons 40-sided die or something, just a normal die. What's all the things that could possibly happen if I roll a die?
1%.
Yes. So then the sample space would be 1, 2, 3, 4, 5, 6. And these little dudes, these little squiggly dudes, anybody remember what those are? Seen those before? Brackets. They're for set notation. So really they're useful for listing finite things. I would use interval notation for an infinite continuous set of things. These are for finite. You can't roll a die and get 2.976. If you can, show me that thing. Infinite sided die. All right. What else you got, Jeff? What about, so if I have, here's a nifty one. So if in a bag I have 2 red, 3 blue, and 6 green poker chips. Let's see if you guys get this. And I pick 2 poker chips. What would the sample space look like? So the sample space is you writing down all the events that could happen. So what's the most basic? If I reach in, what 2 poker chips could I pull out, for example?
3 blue or 2 blue.
I could pull out a blue and a blue. I love it. You guys with me? So if we do this in a systematic way, we won't miss anybody. Or else I could do a blue and a red. Or a blue and a green. Crazy. And then I just keep going. It could have been a red first and a blue and a red first and a red and a red first and a green. Oh no, comma, Jeff. There you go, buddy. Or it could have been a green first and a blue and a green first and a red and a green first and a green. Okay. You guys, you stop there for a second. You guys get the feel for that? Why isn't the set there not just BRG? Because I'm picking freaking 2 chips. So each element has to have 2 pieces to it. So it's sort of like this number 36. Because you're going to pick, you're only going to pick 1 book and number 36. The homework. Right? The thing is, you got 8 fiction books and the rest, and 4 non-fiction books. The fiction books are numbered 1 to 8. How would you show that? This is in the example. So it's 8 fiction books and 4 non-fiction. The 8 fiction books are numbered 1 to 8. And get ready, the non-fiction ones are numbered 1 to 4. Didn't see that? How could I identify, if I pull out a book, how would you identify one possible thing it could be? What would be a nice, concise way? What could I pick? So I have 8 fiction books numbered 1 to 8, and I have 4 nonfiction numbered 1 to 4. So just tell me, what's a book I could pull out? Don't tell me, Moby Dick! No, they didn't tell me. Which one? Fiction 4. F4. All right? You sank my battleship. Do you guys? There are multiple ways to identify these. The most concise way is F for the fiction, N for the nonfiction, F1 through 8, N 1 through 4. I did that problem for you. You just have to put it together. What could happen? I could get F4, or F1, F2, F3. So what are you gonna do? You're just gonna list all that shit and be done with it, right? And move on. So all a sample set means is a collection of all the things that could happen. So if I pulled a card from a deck of cards, what would the sample space look like?
All of the possible cards.
Yeah, it'd be like ace of spades and two of spades and three of spades, all the way up to king. And then ace of diamonds and two of diamonds, all the way up, right? And ace of balloons. No, it's not Lucky Charms. Ace of clubs and stuff, right? Okay, I like it. You guys doing all right? Is that all right? So sample space, not a very difficult idea. Some of the questions are going to be interesting to piece them together. We'll see how you do it. Anything else from homework stuff? That was beautiful because that was led right into lecture a little bit.
Number 42.
I think that's one we haven't. Yeah, okay. So we have some. So let's do this now. I've had two questions related to this. Let's hit it. This is one of those two terminology pieces we haven't gotten to yet. Okay. So there's this idea of mutually exclusive. So we all have an idea of what the word exclusive means. Can somebody, what would exclusive mean? When I say exclusive, what do you think of? If I say it in a certain way, exclusive. But just the word exclusive, where's your mind go? Some of you guys are like, my mind is going anywhere but here. I said, oh, exclusive. What do you think? Special? Specific thing? Limited? If it's an exclusive club, what does that mean?
Private.
Sort of like what you were saying. Private, only certain people can get in there. So it excludes things. So exclusive is the idea of you gotta have a lot of money to go there, or you gotta know the right people to go there, or whatever. How we doing? I like it. They don't want me, I don't want them. So mutually, what about mutually? So exclusive means I've got a club, I'm not gonna let you in. Mutual exclusive is I got a club too, and I'm not gonna let you in either. Nah, we just sit there staring at each other. Right? Pretty much sums up a large part of the world. But mutually exclusive are two events or groups where there's no overlap. Nobody is in both. So, some are just in one place. And so an example I used to use, and maybe now, this is kind of funny how old I am, but I used to use dog and cat. And then some of you guys might know a while back there was a cartoon about this poor creature that I don't want to get into the biology of this thing. Kind of reminds me a little bit about the human centipede, but in a weird turnaround. If you don't know that reference, enjoy your life. You're living a great life. Sorry. It also was from South Park, the Apple iPhone thing. So there was a cat-dog creature, and I apologize to those of you that are like, God, stop going off on these tangents, but I just can't stop. So I'm sorry. So mutually exclusive are two things where if you are one of them, you cannot also be the other. So nowadays I use rocks and ice cream. It's my go-to. You can have ice cream that looks like a rock, but it ain't a damn rock. You with me? So don't give me that shit. So an example of two mutually exclusive events are finding a rock and finding ice cream. If I found ice cream, what's the chances I also just found a rock? 0. So for example, here's something that's not mutually exclusive. So let's see. Mutually exclusive would be rock. Let's say A is rock and B is ice cream. What would not be mutually exclusive would be, for example, the most boring example I can give you is Republican. Nothing against Republican. And female. Are those mutually exclusive?
No.
Good. They're not mutt-X. Because I can find somebody who is in both. I can find a Republican who is a female. Right? I like it. No judgment on that, but just the fact that that means it's not an example of two mutually exclusive events. So help me out. If I had two events, A and B, that are mutually, forever now it's going to be mut X, right, for mutually exclusive. Bless you. What does that mean about this? If A and B are mutually exclusive, what is the probability that I have A and B?
0.
0. Listen really good. You're going to want to write this down. So in a problem, like in the homework, I don't know, maybe on the test or the quiz, I don't know. If I say F and W are mutually exclusive, what can you immediately write down?
0.
For what? Probability of F and W equals. Then if I ask you a question with a formula that's got the and in it, what are you going to put there? 0. So when you read the homework, it's very easy as a student to just kind of gloss over the first sentences. A and B are mutually, you're like, where's the numbers? There's the numbers. We do shit to them. But if you just gloss over that they're mutually exclusive, you have lost the most important thing in the problem. You already know the answer if the question is and. It's 0. Can't happen at the same time. Okay, maybe. So that's all mutually exclusive means. In fact, the picture for mutually exclusive would be like that. No A's in the B's and no B's in the A's, right? Okay. So that's that. That's the easier one. Now let's go into the next bit of terminology. That's the a little bit harder one to get. And before I do that, I think I got a little further in my other class. I think the last equation, before we do more terminology. Oh my God, Jeff, why are you even writing it? Before we do more terminology. What's the last formula we did? I'm going to make you guys look through your notes. Yes. What was that? And remember why this makes sense. Given B, so it has to be out of B. And then what's the only way it could be A is if it was in B also. That formula completely makes sense. Bless you. Did we do a given problem before we knew this formula? Yes. Do I always have to use this damn formula then? No. Will it make some problems harder if I try? Yes. And this is something you're not used to in mathematics. Because when you're in algebra, it's very constrained. You're going to use the algebraic formulas. Statistics is more of a larger idea. Sometimes algebra is great. Sometimes it's not the best thing. And that's something you probably never heard anybody say. Because you don't hear that shit until you're out of it. In algebra, algebra is it. Algebra is the most important thing in the universe. Once you're out of algebra, oh yeah, sometimes it's useful. Sometimes it's the best thing. Sometimes it's the worst thing. It's just one more tool. So what, Jeff? So we haven't, what's the one formula we haven't created yet? The other formula we had was or. I got given, and of course, so the last formula I don't have yet is and. But we do. I just wrote it up here. It's not in the right order though. How do I solve this so that it's a formula for and? How do I get this by itself? Multiply by this. So if I multiply this, what's it become? All right, we have zero connection to this idea yet. We are about to get a bigger connection to this, is my hope. Here we go. So tell me this. You must have done this. If there's a final exam at 7 a.m. the next day, and you go to bed, what do you do in terms of waking up? Do you set one alarm? Has anybody ever set multiple alarms?
Yes.
right? Even maybe said somebody, if you don't see me on the road, call me, because I need to be the hell up. You with me?
Yes.
So most of us have experienced that. It makes sense. Also, what if? So why do we do that? Why would somebody do that?
Make sure they're awake.
Make sure they're awake. So let's say that a certain alarm clock, or your phone. Your phone can do freaking everything. All right, old man Jeff. You should just be able to make a call. All right. Let's say the probability that some alarm clock doesn't work. Let's use this symbol. Doesn't work. There we go. Let's say the probability it doesn't work is like, let's make it 1%. Which honestly is a little high still, but which means 1 out of every 100 times on average it won't work. Now, most alarm clocks are obviously better, but just so it's easier to work with this shit, let's say I have this crappy ass alarm clock that I got from the dollar store, and it's a 1% chance. I'm not saying everything at dollar store sucks. I'm sorry if somebody took offense at that. There's a 1% chance it's not going to work. You guys with me? If I have one alarm clock, then there's a 1% chance that I'm not going to wake up. It's not going to wake me up. So what about if I had 2 alarm clocks? And they're both the same brand. So what's probably that I get 2 alarm clocks that don't work? It can't be, so what does this really mean? The probability the first one doesn't work and the second one doesn't work. Is everybody cool with that? Because that's the only way I'm not going to wake up is if they both don't work. Please be with me. So the rule cannot be the same as for or. I can't just add them. Why would that be insane? Because if I just added these, now I've got a 2% chance instead of just a 1% chance. And we know that's not how it works. That other alarm clock is supposed to be a backup. It's supposed to decrease the chances that I don't get woken up. Are you guys with me? And this, of course, is like backup plans. This is why we have multiple locks if you live in a bad neighborhood. We're like, all right, you're going to get in here, but I'm going to make you earn getting in here. All right? You guys semi with me? So watch this. It's kind of neat. If I have 2 alarm clocks sitting up there next to my bed, or wherever you sleep, and what percent? Jeff, what's your 2 alarm clocks? What? So what percentage of the time will this one not work? 1%. So 1% of the time that one's not going to work. Of those times, how many times will he not work? So of these times, this one won't work 1% of those. I really want this to make sense. So 1% of the time, 1 out of 100 times, that first clock won't work. Of those times, how often will the second alarm clock also not work? 1%. What does of mean in math? How do I do like half of something or 20% of something? No. Multiplication. So if you didn't know what the answer was, I'm not going to hold it against you because it seems like high schools and other schools are not doing a good job. It used to be everybody freaking knew what of meant. It was just, of course we know what of means. Holy shit. And nowadays, I don't know what the hell they're doing down there, but... All right, bless you. But of means multiply. So 1% of 1% is 0.01 times 0.01. Anybody know what that is?
1.
What is it? 1. Oh, I love you guys. What's 1 times 0.01? Let's build up to this. What's 1 times 0.01? 0.01. What's 0.1 times 0.01? We can do this. What's 0.1? All right, I'm going to lose some of you guys, but stay with me. Come on. What's 0.1 as a fraction? 0.1.
1 over 1.
1 over 10. That's the 10th place. You with me? Let me do this just because. We'll see. Side note. What place is this? 12.79. What place is this? 10s. So that's 110 plus 2 what's? What place is that? Maybe, let me put some more numbers. I don't know. Is that the issue? I'm hoping. So that's thousands, hundreds, tens. Do you see how every step I take is dividing by 10? 1,000 divided by 10 is 100 divided by 10 is 10 divided by 10 is 1 divided by 10 is 1/10. So that's the 10th spot. You guys with me? Okay, a little bit. Some of you guys, you're like, well, shit, of course it is. And some of you guys are like, I've never heard that ever. Okay. What do I do? So 1/10 times something means divided by 10. What happens when you divide something by 10? The decimal. When you divide something by 10, what happens to the decimal? It goes back once. Do you guys know that? So 1/10 of 48.7 is 4.87. Bam. It should be easy. Why? Because our number system's based on 10. So when I'm doing shit with multiples of 10, it should be easy. So when you multiply by 17 or something, that gets freaky, right? 10, that's easy as shit. Our number system is based on 10. Just move the decimal around. So 1.1, 1/10 of 0.01 would be 0.001. Bam. So we're almost here. So what's this then? Yes. Which is 1 out of what? Tenths, hundreds, ten thousands. So if you have 2 alarm clocks that have a 1% failure rate and you set them both, overall you now have a 0.01% failure, 1 out of 10,000 times. It won't. And for some of us who are really anxious, we're like, let me get that 3rd alarm clock. How we doing? I didn't use a formula here. I used an idea. 1% of the time he'll fail, and 1% of those times the other one will also fail. Of means multiply, bam. Can't like it. Do you guys remember when the space shuttle blew up? And I hate the fact that when I say that I have to say the first time. Does everybody know that the space shuttle blew up? A couple times. Yes. Obviously not the same. When I was little, I was also a geek then, so it's kind of obvious where I was headed, but I was really big into space shuttle. Lived in Florida. Anybody else live in Florida ever want to go? It's okay if you never lived there. Congratulations. Sorry. I was going to say nothing against Florida, but yes, plenty against Florida. We used to go out and watch the space shuttle. For somebody that day, we didn't go. And then I remember exactly where I was. I was in English class. I was sitting in the first row by the door because maybe I was a geek, but I like to get the hell out of somewhere. I remember that completely. And I remember because then they told us that the space shuttle blown up, and I just started crying. I was, oh, dude, yeah, big time. That first time it blew up, does anybody know why it blew up?
Rubber band?
Not okay. I appreciate that. It's sort of like a rubber band in a sense. But there were these things in the fuel line called O-rings. And what they did, they were like valves. They made sure the fuel went in one direction. Why would you have multiple of them? Because if the fuel goes the wrong way, obviously we know what would happen, exactly what did happen. Right? So why did they fail? Because it was icy that morning and they weren't working up to standards, and their probability of failing went up. You guys kind of all with me? All right, so that was them being, we're like, oh yeah, we're amazing. We've done this before. And then, oops. So, same idea as a couple of alarm clocks. You have multiple, so if this had again, let's say 1% chance of happening. If I have a couple of them now, there's a 0.0001, a 0.01% chance of happening. So I'm gonna have several of them. Icy made them all worse. So it didn't matter how many we had, they all had an increased chance of failure. And that's why that happened. Okay. All right, maybe. Okay. So all that was to show you that and being multiplication makes sense. So now we've got this formula here. I'm gonna write it a couple different ways. The second way is the way we just figured out, but it also works the first way. Because A and B are interchangeable there. If I said you and you, or if I said you and you, it's still the same two people. So it doesn't matter what order they're in. Here's an example of this kind of problem. Let's say I've got 4 red, 6 green, and 2 blue poker chips in this bag. And I want to know, I'm going to pick 2 of them. I'm going to pick 2 chips now. Now, there's 2 main ways I could pick 2 chips. I can pick one, throw that away, and then pick the other one. Or I could pick one and drop it back in, and then pick the other one. Why would those 2 be different in any way? Why should it matter? Beautiful. The denominator would change if I picked it out and threw it away. Right? Or fed it to my little brother. Right? Well, I would explain a few things about it, but sorry, Jim, if you're watching. So if I ask you, what's the point? So I've got to tell you right up here. Let me say with replacement, which means I put the first one back in. So what's the probability I pick a red chip and then a blue chip? All right, let's piece this together. What part of the time will I get a red chip? Nothing's changed here. I haven't picked anything out yet. What's probably get a red chip first thing? 1 12. How many out? 4. 4 out of 12. You got 4 chances to get a red out of the 12 chips. Of those times, how often will I then get a blue chip? And I've dropped that first one back in. Reach back in. Let's probably get a blue chip now.
2 over 12.
Yeah, 2 out of 12. And of course that will be 1/3 times 1/6 is 1/18, which is 0.0. So 0.05. I don't know what it is anymore. 0.05. Anyway, no one's gonna help me. Thanks everybody. 1 divided by 18. I know it's 0.55 forever. Is that what it is? Or is it, come on, math boy? Is that it? 0.5 forever? Thank you. That makes sense to me, but we'll see.
Yeah.
0.055.
Forever.
Yep, forever.
Sorry. Just my one skill. Okay. So what do we just do? Why does it make sense? We know and means multiply. The reason is because 4/12 of the time I'll get a red, and then 2/12 of those times I'll also get a blue. Of means multiply. So now I can just make it and means multiply. Bam. And that's exactly what this says, doesn't it? And equals this times this. Now what the shit is this? This is going to become much more important in a minute. But what's the probability I get a blue given that I picked a red already? Well, it doesn't change because I dropped the first one back in. So what if I do the same problem but I do it without replacement? What if I do this in some other color than purple? That would be amazing, Jeff. All right, sweet. So now if I do it without replacements, probably get a, what did I say, red and then a blue. Well, the red being first, same thing. Nothing's changed. Got the bag. Take out a red chip. Right? Then I throw it. My little brother still gets it. He's become used to it. So 4/12. 4 out of 12 times I get a red. Now, let's probably get a blue. Yeah, there's 2 blue out of 11 chips. So if there was a third thing I was picking, you would just make it out of 10. It's crazy. And means multiply. And then whatever the shit that is. 2/33. Cycle point. I'm not even gonna try. I'm sorry. Whatever 2 divided by 33 is. Zero 6.05 something. Sorry.
Why is it 11?
So I'm doing this without replacement. So the minute I pick that first chip, I throw it away. So why didn't the 2 change? Because there's still 2 blue. So, how are you guys doing? So the main thing there is and means multiply. We've seen several examples why that makes sense. Plus, the algebra just tells us it's freaking multiply. So look here. What's the problem I get a blue given that I picked a red? Because so here. Look at this. By the formula, what should this be? Red and blue. It should be the probability of red times the probability of blue given I picked the red. Isn't that exactly doing the formula? Are you with me? What's in place of A? R. Okay, but that's what the formula says should happen. So where did I get 4/12? That was the probability of red, right? Shit, what did I have? Of course I put 6 with G so they look the same. Good job, John. The probability I get a red first was 4 out of 12. And now I throw that away. So what's the probability I get a blue one given that I picked a red one? Well, it would change the bottom. Given that I picked a chip, there's 1 less chip. All right, good. I'm trying to step you up there. We got this formula just by algebra. But there's an example of, oh shit, what we did is exactly what the formula would tell me to do. Kick ass. Formula makes sense. That's weird. All right, I forgot what this was. Anybody tell me what this was?
06.
06?
Repeating.
Repeating, neat, okay.
No, 06 or.
Oh, 06, the whole thing repeated. Even neater. Kick ass. Okay, I like that. So, what if I had the same setup and I pick somebody to be a camera person? Pick 3 without replacement. What's the probability I get? Let's do it. A green, and then a red, and then another red. So the way I look at this is, how many choices am I making? How many selections? 3.